Owners of a recreation area are filling a small pond with water. Let Y represent the total amount of water in the pond in liters. Let X represent the total number of minutes the water has been added. Suppose that X and Y are related by the equation Y equals 300 plus 34X. Answer the questions below. Looking at my equation and what they give me, I know that Y is the amount of water in the pond in liters. So this equation translates to pond water equals 300 liters plus 34 times the number of minutes the water has been added. So 34 times minutes liters. I wrote it out like that so that I understand my next two questions. What was the starting amount of water in the pond? Now before I hit that, it says note that a change can be an increase or a decrease. So for an increase, it's a positive number. For a decrease, it's a negative number. So if your weight changes, you're either gaining weight, which means you got added on weight, or you're losing weight. So what was the starting amount of water in the pond? The starting amount of water in the pond is saying what is the pond water, or what does Y equal when X is 0, or when you did not fill it, when you use 0 minutes. So 300 plus 34 times 0. Basically, it's asking what did your y-intercept? Where did your graph start? So if X equals 0, my pond water is 300 liters. One, two, three, four. 1, 2. 300 liters. What is the change per minute in the amount of water in the pond? This is the same as our last topic on tables and whether or not something is linear. You know it's linear if the difference in your y values is the same. So let's just make a mini table real quick. We'll only use 3 numbers because this is a linear function. So x is 1, 2, 3. If x equals 1, my y is 300 plus 34 times 1, which is 334. If x equals 2, my y is 300 plus 34 times 2, or 300 plus 68. If x equals 3, my y is 300 plus 34 times 3, or 402. Now, what's the difference between my y values? This is 34. 34 plus 34 is 68. 300 is still 300. This is also 34. 8 plus 4 is 12. 3 plus 6 is 9. Carry the 1 is 0, 10. And 3 plus 1 is 4. So I'm going up by 34 liters every single minute. Now you might be confused as to the math on that, but you never had to do the math to begin with. If you already know that this equation is linear, the rate of change is whatever is being multiplied by x. In this case, my 34, my plus 34, is being multiplied by x, so that will be my rate of change per minute. Per means multiplication, my minutes is x, so my change per minute is what is multiplied by x. And so I didn't have to use my table. My table proves my point. But in a linear function, your rate of change is always whatever is being multiplied by x, carrying that sign. So if this was 300 minus 34, my rate of change would be negative 34 meters. So just to hammer home this point, I'm not even going to read the question. Read the prompt. I'm going to read the question of what is the change in Ruben's distance from Milwaukee for each hour he drives? Per and each are multiplication jargon. So it just asked me if y is the distance from Milwaukee and x is the time driving in hours, what is the change in Ruben's distance from Milwaukee for each hour he drives? So what number is being multiplied by x? Looking at my function, that's that negative 65. So my answer for the change would just be negative 65. And what was Ruben's distance from Milwaukee when he began his drive? That's just saying, what is your function equal to when x is 0? If x is 0, you just get rid of it, so I'm left with 375. And that's a complete problem like this. Your initial point is always going to be your y-intercept. What happens when x equals 0? And the rate of change for linear functions will always be whatever the coefficient of x is, or the number being multiplied by x. And that's it.